झाले सर्व.
Okay, is the slide visible now?
Yes, sir.
Now we'll see the next process. Okay, 4 processes that we have seen: sensible heating, sensible cooling, humidification, and dehumidification. These processes are rarely used as a single process. In actual practice, the combination of these processes are used in practical applications. Okay, so I will be discussing here a next process I have listed here as process number 4 as the cooling and dehumidification. Okay, so I have shown these 3 processes. First process, sensible heating process. Then the second process, sensible cooling process. And third process that I have shown as a dehumidification process. Now I am going to show the fourth process. Okay, so let us show that one. So diagonally toward the left, I have shown an arrow that is in the black color. So this process is known as or is represented rather as cooling and dehumidification process. Okay, so let us see what features are there for this process. This process is generally used in summer air conditioning applications for both the purposes, for cooling and dehumidifying the air. As the title of the process suggests, cooling and dehumidification. So it means that you have to reduce the temperature as well as you have to reduce the specific humidity as well. You have to remove the moisture, isn't it? And this process is done by allowing the air in such a way that it will be passing over, it is admitted over the cooling coil or through the cold water spray. Okay. How this process can be represented on the chart. Okay, I have shown the different points here. Okay, so this is nothing but the point 1 and the process is shown this way. Okay, 1, 2, and 4. I have shown this process as process 1, 2, and 4. So that is the cooling and dehumidification process, isn't it? So initial temperature is TD1 and final temperature is TD2, isn't it? So there is a drop in temperature from TD1 to the TD2, and initially the specific humidity was omega 1 and final specific humidity is omega 2. So there is a decrease in specific humidity. So moisture content is removed from omega 1 to the omega 2, that is dehumidification, and temperature reduced from TD1 to the TD2. So that is nothing but the cooling. So hence it is a cooling and dehumidification process. So the path which is followed by the cooling and dehumidification process is nothing but toward the lower left corner. Okay, diagonally it will be shown toward the lower left corner. Very, very important observation. Okay, so let us see how this is further explored. Yes, dryable temperature of the air decreases from TD1 to the TD2. Okay, and there is a drop in the specific humidity of the air. Okay, specific humidity of the air decreases from omega 1 to the omega 2 in the cooling and dehumidification process. Point number 2. So that is the final relative humidity of the air is normally higher than that of an entering air. Point 3 and point 4. Okay, so point 3 represents the dew point temperature of the incoming air. So air can be dehumidified only when it is cooled below the dew point temperature. Okay, lowest temperature is the temperature at point 4. So this TD4 must be less than the incoming dew point temperature, that is TDP1. Then and then only this dehumidification process can be carried out. Okay, this is the important condition for the dehumidification process to take place. So this is what it is mentioned here. The dehumidification of the air is possible only when the effective surface temperature of the cooling coil or cooling is less than the